Hi everyone, this video is for sections 12.3 and 12.4 for our Math 102 Contemporary Math for Hartford Community College and our Thinking Mathematically textbook. So in the last video we talked about the mid-range, which I said you probably have never seen before, and it's similar to, or it's not the same as the range. Now we are actually going to talk about the range. And we use the range to describe the spread of data items in a data set. So your range is the difference between the highest and the lowest data values in a data set. So again, you take the highest value, subtract the lowest value, and it gives you your range. So here's an example of range where they are looking at the age of the 4 oldest presidents in the United States. And the oldest was Trump at the age of 70. The youngest in the 4 oldest presidents was Buchanan at the age of 65 when they started their first term. So the range would be 70 minus 65, or the range of 5. The next thing that we're going to look at in this section is how to find the standard deviation from a mean or an average. So the first thing we're going to do is we're going to find the deviations from the mean for the first 5 data items. So the first thing you have to do when you're finding the deviations or finding the standard deviation is to first calculate the mean. So we are calculating the mean for our says 4 or 5 data items, but it's really 4. For the 4 data items that we have, which are 70 plus 69 plus 68 plus 65, gives us 272, and we divide by 4. So the mean is 68 for these 4 data points. And what we're going to do to find the standard deviation is first you find the mean, so we did that. Then you find the deviation of each data item from the mean. So you're going to take the data value and subtract the mean from it. And that's going to be your deviation. Then you're going to square each of those deviations. So whatever you found was your deviation, you're going to square it. You're going to add all of those answers together, all the values that you squared. Then you are going to divide that sum by n minus 1, and n is the number of data items. So in our case, we had 4 data items, so we would do 4 minus 1, and we would divide by 3. And then after you do that, you're going to take the square root of that value, and that will give you your standard deviation. All right, so we found here the mean to be the age of the 4 presidents of 68. The deviation would be you take each data point and you subtract the mean. So we took 70 minus 68. We had a value of 2. 69 minus 68 is a value of 1. 68 minus 68 is a value of 3, or excuse me, 0. And then 65 minus 68 is a value of negative 3. So these would be the deviations from the mean. Next, if you recall, the next step you want to do is you want to take each deviation that you found and square it. So if we look, we have 2 squared is 4. We have 1 squared is 1. 0 squared is 0. Negative 3 squared is 9. And then we're going to take these 4 values and add them together to get the sum of 14. And now what we need to do is we need to divide our 14 by n minus 1. So again, we had 4 data points. 4 minus 1 is 3. So we have 14 divided by 3. And again, a lot of times you're going to get a decimal. You're going to want to round it probably to 2 place values, but just look to see, what they say and how far they want it rounded. So we ended up, when we rounded, to 4.67 approximately. And then you take the square root of that value. So the square root of 4.67 is approximately 2.16. And that is the standard deviation for the set of data points that we have. All right, and that is going to bring us to section 12.4, the normal distribution. We're going to take a look at some more things that will help us with looking at different data and statistics. So when we talk about the normal distribution, we are talking about probably something you've heard about before, the bell curve. Normal distribution is always bell-shaped and symmetric about the vertical line that is through the center. And with normal distribution, or that perfect bell curve, your mean, median, and mode are all equal, and they're located at the center of that distribution. So you can see here on the slide, we have just different examples of what the bell curve would look like, different types of graphs. We have some histograms, and then just your standard bell curve is that last one on the bottom. So the shape of your normal distribution depends on the mean and the standard deviation. So it's always going to look bell-shaped, but these three graphs, all have the same mean, but different standard deviations. So you can see your bell does not have to, some are really tall, some are, medium sized, and others are flat. And again, that just depends on the standard deviation. The larger the standard deviation, the more the distribution becomes spread out. But it still has that, it's symmetric on both sides. The mean is always the center of that bell curve. All right, so we are going to look at standard deviation and the 68, 95, 99.7 rule. And really what this is saying is, here we have an example. Here's one of our bell curves. And approximately 68% of the data items fall within one standard deviation of the mean, and again in both directions. So really, if we look here from the 0 or the mean to the first standard deviation going down 1, I know that you can't really read that, that is, there's 38% of our data. And then on this side, again, there's another, not 38, but 34% of our data, and this is 34%. Together, when you add those up, they make 68% of our data. So 68% of our data will always fall, if you have a normal bell curve, within one standard deviation of the mean. Approximately 95% of the data items fall within 2 standard deviations of the mean. And then 99.7% of all data items fall within 3 standard deviations of that mean. So, if I were to look at my data from 3 standard deviations all the way over to the other side, 99.7% of my data could be found there. All right, so here we have, we know that the average or mean of an adult male is 70 inches, and there's a standard deviation of 4 inches. So that means, for every standard deviation, it either goes up or down 4 inches. And they want us to find the height that is 2 standard deviations above the mean. So think above, it's going to get higher than the mean. So here we know that our mean is 70, and they want 2 standard deviations above. So they did 2 times 4, because 4 is our standard deviation. So you would add 8 inches to your height. So 70 plus 8 will give us 78 inches. And that would be the height that is 2 standard deviations above the mean. All right, now we're going to use that bell curve. And they want us to find the percentage of men in North America whose heights are between 66 and 74 inches. So 66 and 74. Now we know that our mean is 70 with a standard deviation of 4. So if we add 4 to 70, we get to 74. So it's 1 standard deviation away. If we subtract 4 from 70, we will get 66. So between 66 and 74 inches are going to be 1 standard deviation away on both sides. So remember, that is equivalent to 68% of our heights are between 66 and 74 inches. All right, sometimes you'll be asked to calculate the z-score, and what a z-score is it describes how many standard deviations a data item is above or below the mean. So the z-score, and you have to have a normal distribution for your z-score. To find your z-score, you're going to take the data item minus the mean, divided by the standard deviation. If your value is positive, it means it's above the mean. If it's negative, it's below the mean. And if the z-score is 0, it is the mean. So the mean, if your z-score is 0, that value is the mean of the data. All right, so what we need to do is they want us to find the z-score for a weight of 9 pounds. And we know, here we have the mean weight of a newborn infant is 7 pounds. And the standard deviation from this is 0.8 of a pound. So what we want to do is we want to find the z-score for a weight of 9 pounds. So to do this, we are going to take our data value, and we can kind of see it on the chart there, but we're going to take our data value of 9, subtract the mean of 7, and then we're going to divide it by our standard deviation of 0.8. All right, so 9 minus 7 is 2, and then we'll divide that by 0.8, and when we do that, we get 2.5. So that means that an infant who weighs 9 pounds is 2.5 standard deviations above the mean, because it's a positive value, so it will be 2.5 standard deviations above the mean. Right, so sometimes they're going to give you the z-score and ask you to find the data point or the data value. So to do this, here we're looking at an IQ test, and it has a normal mean of 100 and a standard deviation of 16. So they want to know the IQ corresponding to the z-score of negative 1.5. Now remember, if you have a negative z-score, that means it's going to be below that mean. So our score is going to be below 100. And the way that we would find the mean or the IQ score is you would take your mean minus the standard deviation that you have times whatever z-score you get, so 1.5. Now we're doing minus because we know it's below, it's a negative, but if it was positive, you would add it, so you would take the z-score still times the standard deviation, but add it to the mean. So we did 100 minus 1.5 times 16, my standard deviation, which is 24. So 100 minus 24 will give me 76. So that means the IQ corresponding to a z-score of negative 1.5 is going to be 76. All right, in this last slide, we're just going to talk a little bit about percentiles and quartiles. You have probably, heard before, a lot of the times, especially with like little kids, they say, oh, their height is in the 50th percentile, or their height is in the 100th percentile, or something like that. And really what they're talking about there is they've looked at the heights of, we'll just talk about heights of children, maybe like a 5-year-old. They have looked at the heights of, thousands of 5-year-olds, more like, hundreds of thousands, and they have determined the mean height or the average height. And then again, it is a normal distribution, a bell curve type of graph. And from that graph, we have the mean height, which is in the 50th percentile. So if you're in the 50th percentile, that means you are pretty spot on average for that age. And then, if you are in the 25th percentile, that means that you are, shorter than the average person. If you're in the 75th, you're taller than the average person. They're divided into quartiles. So again, you have the first quartile is the first 25% of the data. And then, so that would be right here. The second quartile goes from 25 to 50%, and that's another 25%. Then you have 50 to 75, and then the last quartile, you'll have 25 to 100%. So again, it's just like if you hear those comparing, they say, oh, they're in the 20th percentile, 25th percentile. That's where they're getting the information from. It's really coming from that bell curve and that normal distribution.